Hey everyone, let's talk about 4.4. Today is going to be all about solving linear systems that have three variables in them. So far you guys have been working with systems that have x's and y's. Now we're going to start dealing with systems that have x, y, and z. So these problems are going to be kind of long. Just bear with it for a little bit. Just know that you need to show your work, and it's very important that you're organized with your work. That's going to be the most helpful in being successful in these problems. So first off, I just want to show you what a solution looks like if we're solving a system with three variables. So there's still two ways of solving systems. We can still do substitution, or we could do elimination. So whichever way they tell you to, or whichever way you're most comfortable with, just pay attention to the directions. These are our two ways of solving. But our answer, instead of being an ordered pair like x and y, we now have three variables. So our answer is what's called an ordered triple. Okay. And an ordered triple is just x, y, z. So it's still an ordered pair, okay, but now instead of just having x and y, we have three, x, y, z. Okay? So this is what our solutions are going to look like. We're going to get x, y, z on their own, and then we're going to write them as an ordered triple. So let's just jump right into an example. All right, so our first example here says that we have these three equations. So what you should notice is that we've got some that have x, y, and z in them, some that just have 2, and so forth. So when you've got three variables, that's how you know you're solving, and you're going to have an ordered triple. And the way you can really tell, the best way to tell if you can use substitution easily is if the variables are not all lined up, or if a variable is solved on its own. So for example, right here, we have that z is equal to negative 3x minus 1. It's already z equals something, so we're probably going to be using some substitution to plug this equation in wherever we see a z. Now, when you are doing substitution, okay, if you pick an equation to plug in, you're going to plug it into two different equations. In this case, the z is our middle equation, so we're going to plug it into the top here, and we're going to plug it into this z here. So basically, wherever you see a z, you're going to replace it with negative 3x minus 1. So let's go ahead and do that. So we're going to plug in for z. So our first step would look like this. The top equation, we're going to have negative x minus y minus 3 times whatever z is equal to. So that's negative 3x minus 1, and then equals negative 9. So remember, wherever we see a z, we're changing it to what its equation is. And now we're going to go ahead and simplify. So we have negative x minus y, distribute the 3's, we get positive 9x, and then positive 3 equals negative 9. And now we can just combine like terms. Negative x plus 9x, that's going to give us 8x. There's no y's, so we'll just leave it the same. And I'm just going to move this 3 over to the other side. So subtracting 3, we get equals negative 12. Okay, so this is kind of like your step 1. And I'm going to just underline it. It's not an answer, but I'm just going to underline it so we know where to refer to it. All right. Now we're going to do the same thing with the bottom equation. So we're going to have x equals 5y minus our z equation, so negative 3x minus 1, and then plus 23. Alright, so I'm going to go ahead and distribute the negatives here, so we get x equals 5y plus 3x plus 1, and then plus 23. Alright, so you've got to be very careful with order of operations here. Then we're going to combine like terms. I'm going to move this 3x over to the other side. Okay. So I get negative 2x equals, there's no other y's, so 5y, and then 1 plus 23 is 24. Now, what you should notice here is that we still have an equation with an x and a y in it, and we're still using substitution. So because we're still using substitution, we're going to have to plug something in again. This is why these problems get long, because you have to break it down till you get to one variable, and we're only at 2 right now. So now I'm just going to go ahead and use this equation on the bottom because it's almost got x by itself. I'm going to go ahead and solve for x. So if I do that, I'm going to do this off to the side here. I would have negative 2x equals 5y plus 24. Alright, so I'm going to divide everything by negative 2. Okay, and I would write it individually so it doesn't confuse you. So we get x equals negative 5 over 2y, and then 24 divided by negative 2 is negative 12. So here's our equation. Okay, what we're going to do is use the other equation that I underlined in blue, this one right here. Okay, and we are going to plug it in wherever we see an x. By doing that, we're going to have an equation that's just y's. Right? So I'm going to go ahead and do that in red. Okay, so I'm going to have 8 times Okay, so we've kind of gone from here to here, here. I'm kind of drawing arrows where we're going. All right, so 8 times my x equation, negative 5 halves y minus 12. And the rest of the equation, minus y equals negative 12. And now we can go ahead and solve. So distribute the 8 across. We end up getting negative 40 divided by 2, which is negative 20y. Negative 12 times 8 is negative 96. Minus y equals negative 12. And now we have an equation that's all y's. That's a good thing, because now we can solve for y. So we'd have negative 20y minus y, that's negative 21y. Add 96 over, and we get positive 84. And then last but not least, we can divide by negative 21. And when we do that, we get that y is equal to negative 4. Okay, so there's our first solution. Now we're not done because we only have y, and remember our answer is an ordered triple. So now what you're going to do is just work backwards. You're going to take your y value. I would go ahead and I would plug it in here where you have an x equation. Okay, so it's a lot of working backwards. All right, so this is why I said you got to keep very organized with your work. So here we would have x equals negative 5 halves times our y, so negative 4, and then minus 12. So we get 20 divided by 2, which is 10. 10 minus 2, or sorry, 10 minus 12 is going to get us x is negative 2. So there's our x value. And then last but not least, we want to find our z. Well, up at the very beginning, okay, we had an equation. Oh, sorry, guys. We had an equation for z. It was right here. And in order to solve for it, we needed to know what x is. Well, the good thing is we know what x is now, so we can go ahead and plug that in. So I'm going to use my green. So what is it, negative 3x minus 1? Okay. I'll extend that down. So we're going to have z equals negative 3 times our x value, which was negative 2, and then minus 1. So that's positive 6 minus 1, which is z is equal to 5. So now we have all three answers, x, y, and z. The very last step is to write it as an ordered triple. So x comes first, then y, and then z. Okay. So there's our answer. So all I did the whole time was substitution. All right. So we're plugging in for a variable in 2 equations. So we narrow it down to 2 variables. Then we're going to do that one more time, substitution, so that we can get it down to 1 variable. All right, so that's all we want. So you're substituting until you get to 1 variable, and then you're just plugging it in to find your final solution. All right, so go ahead, and I would like you to try this one right here. We've got 3 equations set up. I want you to use substitution, right? And you're going to take this z equation, okay, wherever you see a z, plug that in. Okay, so I'm plugging into the top 2 equations. Then I'm going to solve for either x or y. It doesn't really matter. Okay, and then you're going to substitute again so that you can solve for 1 variable. All right, so pause the video, try that one on your own. All right, so this was the example that you should have gone through on your own. What you should notice is, and I did a lot of work on my own in the pause, but make sure if you have any questions over this example you ask. But what I did first was I took that z equation where it was x plus 5 and I plugged it into the 2 top equations. So when I do this, this is the first one. Okay, so I plugged in that x plus 5 and I solved and I got this equation, negative 4x minus 3y equals negative 9. Then I did the same thing for the second equation. I plugged in wherever there was a z, I plugged in x plus 5 and I distributed. Okay, and then I simplified. Well, this one I end up getting y equals 3. It solves all the way. So that takes care of an extra step actually. So I already know what my y is, so now I can go back and I can plug it into this equation I underlined in red. So that's what I did here, okay? And I just wrote it in green. So I plugged in wherever I see a y, I plug in 3, and now I can solve for x. Once you have, and I got x was 0. Once you have x and y, go back to your z equation and plug in what x is. Well, z was x, which was 0, plus 5, so z equals 5. So I've got all three variables. Write it as your ordered triple. You should be good to go. All right. Let's take a look in this example right here, where if I want you to use elimination. Okay. So in elimination, whoops. Let's go back. Sorry, guys. There we go. Okay. And elimination is most of you are going to like this method better. You want to pick a variable that you want to cancel, okay? Okay, so you guys have done elimination with 2 equations. Now we're just going to do it with 3, and there is a little bit of extra steps involved. So let's say I'm looking at my equations here, the top and bottom, or top and middle. Well, looking at these 2 equations, it would be best to cancel out my y's because it's already -3 here and +3 here. So I'm going to choose to cancel out my y's. So because they're already the same number and opposite signs, I can just go ahead and add. So I'm going to add the top and bottom. So x plus 2x is 3x. My y's will cancel here, okay, and then 3z minus z is positive 2z, and then -4 plus 15, that gets you 11, okay, so that's the first and middle. Well, now I have to do the same concept, but this time I have to do it for the middle and the bottom, okay, so I'm going to overlap that in blue, okay, so this time I have to cancel my y's out because I canceled the y's out in the top, so make sure you're always canceling the same variable, alright, so, excuse me. I'm going to add my equations, so 2x plus 4x, that's 6x. My y's will cancel because they're already the same, okay? And then -z plus -z, that's -2z, okay? And then when I want to add 15 plus 19, okay, you can do that, and you get 34. So what I've done is in both the top and the middle and the bottom, I've canceled out all the y's. Now I've got an equation that's only x's and z's, and I can do elimination again, okay, to go ahead and simplify it further. Well, notice that the z's are already the same number and opposite signs, so I would cancel out the z's. So I don't have to multiply by anything because they're already the same, so I'm going to add my equations. So when I add them, 3x and 6x is 9x. My z's are going to cancel. And then 11 plus 34 is going to get me 45. So 9x equals 45. And now I can go ahead and solve for x. So I'd have 9x equals 45. So divide by 9 on both sides, we get x equals 5. And now I can just work backwards. So I already have x is 5. Plug it into one of these equations. That's just 2 variables. Okay, so maybe I have 6 times 5, because that's the x, minus 2z equals 34. 6 times 5 is 30, okay, 2z. Subtract 30 on both sides. This is just basic algebra, so you guys should be able to do this. So -2z equals 4, and divide by -2, we get z equals -2. Okay, so there's my z value, and then last but not least, plug z and x into one of the equations from the original. I'm just going to go ahead and pick the top one. So we'd have x, which was 5, minus 3y, because we don't know what y is, plus 3 times -2 equals -4. Okay? Simplifying, 5 minus 3y minus 6 equals -4. 5 minus 6 is -1. Okay? And then add 1 to both sides. We get -3y equals -3, and y is going to equal 1 in that case. So now I've got my x, y, and z. Remember, your very last step is to write it as your ordered triple. So x is 5, y is 1, z is -2. So there is my final answer. Okay, so in elimination, you have to eliminate one variable in all 3 equations, not just one of them. You have to pick one and stick with it. Okay, and then do elimination again to get down to one variable. So 2 or 3 rounds of elimination. Okay, and then you can go from there. If you have any questions about this type of example on elimination, please let me know. But both methods are equally correct. It's just what you prefer or whatever the directions ask for. So if you have questions, please make sure you ask me before you go on to your mastery check. That way I can get them answered, and then you should be good to go. Thanks for listening.